Supercomputers are no longer just research tools. They have become engines of global power. The country controlling the fastest AI systems may influence economies. Military and tech few realize how secretive this competition has become over the last decade globally. AI isn't just software. It requires extraordinary hardware and massive amounts of energy. Training advanced models takes thousands of specialized processors running non-stop. Europe focuses on AI ethics but lags in building raw computational power needed. Small countries rarely compete yet remain dependent on other nations. Technology energy requirements for supercomputers are staggering and shape location decisions. Governments grant special energy access to facilities considered strategic assets. Supercomputer sites are often located near power plants or renewable energy sources. Every site is chosen to minimize disruption and maximize uptime for continuous use. Security is critical. From cyber threats to strict physical access controls at every site. Industrial espionage targets chips and algorithms that power these advanced machines. Stealing designs can provide years of advantage in AI capabilities and performance. Nations invest billions to maintain secrecy and retain technical dominance worldwide. Corporate and state competition is intertwined and largely opaque to the public. Specialized chips, including GPUs and AI accelerators, form the backbone of these machines. Manufacturing of these chips is concentrated in just a few factories around the world. Supply chain disruptions can completely halt AI progress in entire countries. This gives nations leverage beyond raw computational speed alone in strategic ways. Access to advanced chips is now a geopolitical weapon disguised as technology. Trade restrictions and export controls shape who can develop cutting-edge AI models. The United States has restricted some high-performance chips to selected nations. This is not only technological, it is deeply strategic and highly political. The fastest AI supercomputers can accomplish tasks unimaginable just a decade ago, from predictive analytics to climate simulation. They process massive data streams. Military applications include autonomous systems and real-time intelligence analysis. Financial sectors leverage AI for high-frequency trading and market prediction. Corporations use these machines to train language models and recommendation engines. Each new generation expands both opportunities and potential risks for nations. The speed of AI training determines who leads global innovation and development. Every delay in hardware procurement translates into lost strategic advantage. Countries secretly monitor each other's AI supercomputer progress constantly. Satellite imagery, patents, and trade data are used to track new installations. Some AI labs operate entirely in underground or fortified facilities for secrecy. Exact specifications of these machines are classified in almost every nation. Even employees often cannot see the full system or understand its capabilities. Digital security protocols prevent unauthorized access at every possible level. Physical security is equally rigorous, including guards and biometric authentication. Insider leaks can cause global repercussions in the AI development race. Funding is secretive, routed through defense, research, and energy departments. The scale of these projects is immense, often costing billions annually. Only a few nations can maintain continuous supercomputer upgrades and maintenance. AI research is increasingly competitive. Where speed of experimentation matters, faster machines allow more iterations, improving models before rivals catch up. Press releases often exaggerate progress for strategic positioning and influence. Meanwhile, secret labs test models that could surpass public understanding. Some machines are hidden entirely from rankings to protect strategic advantage. Collaboration in AI is selective and often restricted to trusted partners. Only industrial alliances shape who can access which technology legally. Worldwide trade sanctions are used strategically to slow competitors without open conflict. Energy, hardware, talent, and secrecy are all intertwined in this global competition. Recruitments are aggressive, with high salaries and incentives to retain top minds. Brain drain becomes a tool for gaining competitive advantage in technology. Countries sometimes restrict academic publications to protect sensitive knowledge. Collaboration with foreign researchers is tightly controlled and monitored. Data access, both civilian and military, is a key competitive advantage today. Nations increasingly regulate data flow to protect AI development efforts. AI supercomputers are no longer optional. They are central to strategic dominance. Whoever controls the fastest models can predict trends and global decisions. Financial forecasting, disaster response, and defense all depend on computational speed. Supercomputers define technological leadership before public awareness exists. This is why nations hide projects and restrict discussion in the public sphere. Even satellites, sensors, and communication networks feed these machines. Real-time processing of global data is possible only with massive supercomputer systems. The advantage grows exponentially with speed, scale, and specialized infrastructure. Competition is quiet but fiercely strategic, affecting the global power balance. Breakthroughs include energy-efficient chips and quantum-assisted AI processing. The stakes are not academic. They are political, economic, and highly strategic. Countries plan decades ahead. They are political, decades ahead, forecasting rivals' development timelines carefully. Open-source data provides hints but rarely full insight into capabilities. Governments rely on intelligence and trade information to estimate rivals' power. Strategic decisions are made using incomplete but highly sensitive datasets.